Okay, so this topic is significant figures. And unfortunately, once again, I forgot to have the microphone on when I recorded this originally, so we're going to go through it just like this. Alright, so what are significant figures? They are the valid recordable digits for a given measurement. Two more terms we need to know are precision and accuracy. Precision is the degree of exactness to which a measurement can be reproduced, and accuracy describes how well the result agrees with an accepted value. So for example, I know you don't see me right now, but if I said Mrs. Cunningham is 2.56789 meters tall, well, that's got a lot of digits, so it is a precise number, but it's certainly not very accurate. 2.5 meters tall, picture a meter stick. That's a little over, a yard. So 2 yardsticks, 2.5 yardsticks together, I'm certainly not that tall. So this is a precise measurement, but it's not very accurate. Okay, so what is the length of this object with the appropriate number of significant figures? So how you determine this is basically you've got to realize that the last digit you record is always a guess. So I can tell that this is between 41 and 42. This looks like a meter stick. Always know that that slightly longer division in between, it's got to be halfway. So that's 41.5 right there. And it looks like it's another tick mark past, so that's going to be 41.6. But it really looks like it's a little bit past that. But I don't have any more tick marks, so I don't really know how far past that it is. So that is my guess. I think it's 41.6, and I'm going to throw in the 2. That last digit is called the uncertain digit. It's our guess, it's our estimation. And it's really important that we always include our guess so that other people know how precise our number was and really how good our measuring equipment was. 41.62, that 2 tells other people that I measured this object with a meter stick that had all of these little millimeter divisions. If we didn't have these little extra tick marks, let's say I had the 41 marked off, I had the 42 marked off, but I didn't have any of these markings in between, then I would know, okay, well, it's between 41 and 42, so I would guess maybe 41.6, but people would know that that 6 was my guess. I know it's more than 41, I know it's less than 42, but I wasn't really sure where it was in between. So the number of digits you use tells other people how good your equipment is. Why does this matter? Why don't we just use as many digits as we feel like? Aren't more digits better? No. All right, so here's an example I made up. Let's say you work at a zoo and the monkey in the zoo is sick. And the monkey needs some tranquilizer so that we can put him down and then operate on him. And the amount of tranquilizer this monkey needs is between 117 and 125 milliliters. Any more, maybe it would be lethal. Any less, maybe it wouldn't actually put the monkey down. So we talk to the elephant lady and we talk to the mouse lady and we come up with, we see how much tranquilizer they have on hand because we don't have any tranquilizer left. But this was our magic number that I made up. We need between 117 and 125 milliliters. So we talk to the elephant lady and she is using this piece of measuring equipment right here, sort of a plastic beaker. And she tells us that she has 61 milliliters of tranquilizer, which makes sense looking at what we have here. These divisions must be going up by 10, 10, 20, 30, 40, 50, 60, but she thinks it's maybe just a little bit above that line, so she made it 61. But again, that 1 is her guess. That's her uncertain digit. So we're not really sure if it's 60, 61. And if I wanted to tell somebody it was 60, I would actually have to record it as 60 with a decimal place, just sort of hanging out there. So I know it's at least 60, but we're not sure if it's 60, 61. This is what we've got for a measurement from this piece of measuring equipment, which is not as good, not as precise as this graduated cylinder. So The lady that deals with the mice has this graduated cylinder. She pours out some tranquilizer. And remembering how to measure with the meniscus, we're going to say, okay, well, here's 50 milliliters right here. Here's 60 up here. Again, that little mark that sticks out must be halfway, so that's going to be 55, not 50.5, be careful there. So it's 55 here, 56, and again, she thinks it's just a little bit over that line. Remember, measure the bottom of the meniscus. A little blurry picture, but we're going to measure it just over that line. We're going to say it's 56.1. So that 0.1 is the guess. We know it's at least 56. Maybe it's 56.1, maybe it's 56.2. You know, we're not really sure about this 0.1. So, can we combine our tranquilizers and just say, okay, well, we've got 61 here, 56.1 here. We must have a total of 117.1 milliliters. That's simply how we would add. Is it fair to say that? Is it valid to say that we have 117.1 milliliters total? And the answer is it's not. Certainly can't be if this one was originally a guess. So if it should have been, let's say, 60, and this was a guess, then we would really have had, you know, about 116 milliliters, which if we went back and looked at our range, well, 116 would not have been enough to tranquilize the monkey. So significant figures certainly matter, especially when we start applying math to them. We cannot just always use as many decimal places as we like because we think that's better. In this case, it is not valid to do that. So, how do we do math with significant figures? Before we do the math, we need to figure out what actually is a significant figure. So we've got 4 rules here. The first rule is pretty easy. If it's a digit that's not a 0, it counts. It is considered significant as part of your measurement. So 96 grams, okay, that's 2 significant figures. Those 2 digits both matter. 61.4 grams, 3 digits there. None of them are zeros, so they all matter. And then we have sort of an issue here, 0.52 grams. Does the 0 matter? Well, in this case, no. And we'll talk about when zeros do matter. So just the 5 and the 2 were really part of the measurement, and they are considered significant. Rule number 2, 1 or more final zeros used after the decimal point are always significant. So, okay, first number doesn't have any zeros, 4.72 kilometers. Well, that's 3 digits, that's 3 significant figures. But what about here? 4.7200 kilometers. Well, these must matter. These must be part of our measurement. And whatever we were using to measure distance, this piece of equipment was more precise than the piece of equipment above. Why would we bother putting these zeros here unless they were part of our measurement? So really that last 0 was our uncertain digit. That was somebody's guess. So all of these digits must matter. If it doesn't seem like there was any point to putting those zeros there, well, then they must be part of the measurement. So in this case, 1, 2, 3, 4, 5, all 5 of these digits count. These are all significant. Same with the 82.0. Well, why bother putting the 0 there at all? It must have been part of my guess. And it is showing how precise my equipment is. Okay, this is another easy rule. Sandwich zeros always matter. Okay, 5.029, that 9 was the guess, so all of these digits are part of your measurement. They all matter. So that's 4 significant figures. Again, another sandwich 0. We've got a whole number on either side. 3, all of those matter. Okay, and the last rule. This one can be a little tricky. Zeros used solely for spacing the decimal point are not significant. These zeros are placeholders. And this can be maybe a little tricky with the larger numbers. So if you have 7,000 grams, you know, how good was your equipment? Was your equipment really measuring 1 gram at a time? Or was your equipment measuring, 10,000 grams at a time? because really the 7 is the guess in this case. So this is actually considered one significant figure. If you can imagine a piece of equipment that's measuring 10,000 grams at a time, where the 7 is the guess, only the 7 counts as part of our significant figures. Now, let's say I did have a piece of measuring equipment that measured all the way down to a gram, and I thought my measurement was 7,000 grams, where I wanted people to know that this last 0 was my guess. Well, in that case, you actually just do have to write that decimal place, and if that decimal place is there, then all of these digits matter, so that would be 4. Lastly, for small numbers, numbers that come immediately after the decimal place are considered space holders. So this 783 was really the only part, or really the only digits that were part of my measurement. So there's only 3 significant figures here. So a little tricky. Look over some of these examples and let's do a few more. You should probably pause and take just a minute to try this on your own slide of notes. Just maybe write faintly off to the side so you can erase if you got them wrong. So just take a second to look through these and then we'll go through them. Okay, starting with a tricky one right off the bat, 20 kilograms. Well, if there is no decimal place here, this 0 is considered a space holder. So this is actually one significant figure. Same with number 2, 0.0051. These are all just placeholders. Only the 5 and the 1 are part of your measurement. So that's 2 significant figures. 11, okay, no zeros to worry about at all. You know, unless there's a 0, it should not be a problem to figure out how many significant figures you have. So that's 2. Number 4, all right, got a lot of zeros here. But this first one here is really just a placeholder. Then, of course, we have our 1, and then, well, why bother putting this 0 here at all? It's not going to change my value if I get rid of it, right? My calculator wouldn't think anything different between 0.010 or 0.01. So it must have been part of my measurement. This one must matter. So this is 2 significant figures. All right, number 5 is a sandwiched 0. So that's going to be all 3. Number 6, again, these are just placeholders. So that is 1 significant figure. Same with number 7. This is a placeholder. Only the 8 and the 9 are part of my measurement. So that's 2 significant figures. Number 8. All right, we got a lot of zeros, but again, the ones in the beginning are really just the placeholders. It's the 9 and the following zeros that count. So that's 3 significant figures. All right, now we've got 100.0. Well, if you look back at like number 1, if there was no decimal place at all, we wouldn't count that 0 as a significant figure. But by throwing in this 0.0, which again would seem unnecessary, why would we bother putting that there? Our calculator would think 100.0 and just 100 are the same exact number. The reason that 0 is there is because it must matter for our measurement. It must be telling us that we have actually a really precise piece of measuring equipment. It measures out to 1 gram, and then our last digit was the guess. So that's got to be all of them. All of those digits are significant. That's going to be 4. But on the other hand, for number 10, you got 200 liters here. Well, there's no decimal place at all. So maybe this was a piece of measuring equipment that was measuring 1,000 liters at a time, and we just guessed it was 200. Wasn't even up to 1,000. So that's the uncertain digit, so it's just the 1, just 1 digit. So take a look back through these as we're going through the notes. This will help a little bit. Just pay attention for your placeholder zeros. Those can get a little tricky. All right, so doing math with data, multiplying and dividing significant figures. We're going to have multiplying and dividing rule, and then we'll have an adding and subtracting rule. So multiplying and dividing, again, I'm assuming that you have simply a very basic, dollar store calculator, something that doesn't do exponents. So we can do very basic multiplying, dividing, adding, subtracting, but you got to know how to do the rest. So the first thing you want to do is simply multiply. If you were saying 3.22 times 2.1, you multiply it on your calculator, you get 6.762. Fine. But that is not an appropriate number of digits to record. When you're multiplying and dividing, you have to count the number of significant figures you have, like we just went through. So your answer has to have the same number of sig figs as the number in your calculation with the least number of sig figs. So you did your multiplying, piece of cake. Look at your numbers you started with and just figure out how many significant figures there are. 3.22, okay, I don't even have any zeros to worry about, no big deal. That's going to be 3 significant figures. 2.1, how many significant figures were there? Just the 2. Alright, so if I started with 2 numbers that had 3 significant figures versus 2 significant figures, my answer cannot have more than these. And again, here's your rule. You've got to round your answer so it has the same number of sig figs as the number in your calculation with the least number of sig figs. So what is less, 3 or 2? 2. So my answer has to have 2 sig figs. No more, no less. So to have 2 digits, okay, of course I would keep the 6 point, and now I'd maybe keep the 7, but I do need to round. Look to your right, you know, should that 7 round up? Should it stay a 7? Well, if there's a 6 to its right, that would bump it up. So my answer should be 6.8. Of course, this had 4 sig figs to begin with, which is too many. But my answer should be rounded to 6.8. All right, let's talk about constants just for a second. Constants do not affect significant figures. So if you have a formula such as, you know, the diameter is 2 times the radius. Okay, well that 2 is not a measurement. There aren't any significant figures there at all. That's not a measurement anyway. That's a constant value. So we would kind of assume it's got 2.0 on forever. So just ignore the constant when you're multiplying or dividing. So if the radius was 2.2, you know, that had 2 significant figures, so 4.4 is appropriate there. Okay, now adding and subtracting. Sort of like our tranquilizer example. Alright, so once again, you want to add and subtract some measurements. It's fine. You can just go ahead, get your calculator out, type in all the digits you see, add, subtract, whatever you're told to do. But then you will have to round your answer again. But we are not rounding it the way we did multiplying and dividing. This is a little different. We're going to round to precision. We're going to round to the least precise number in the calculation. So let's say these are all distance measurements. Maybe we've got a fencing company and we've got 3 people working and they've got different materials. And we need to know the total length of fence we have. And somebody tells us they've got 24.685 meters of fence. The next guy says he's got 2.38 meters worth of fence. And the last guy says he's got 3.6 meters worth of fence. So we add them all up and we get 30.665 meters worth of fence. Is that my answer? Can I just say I know I've got 30.665 meters of fence? Where technically somebody would think that that 5 was a guess, so we knew for sure that we had 30.66 meters of fence, again with that 5 being a guess. No, we certainly can't tell someone we had 30.66 meters of fence for sure when this person's 6 here was a guess. If that 0.6 was a guess, well then I certainly couldn't tell somebody that my full answer was this precise. So this is not a counting sig figs problem. I don't care that there's 5 sig figs here, I don't care that there's 3 sig figs here, I don't care that there's 2 sig figs here. This is not a counting sig figs problem. This is determining which number is least precise. And by that you basically just look at the decimal places. All right, so 3.6 only has one digit after the decimal place. So 3.6 is the least precise number. This person had the worst piece of measuring equipment. So my answer cannot be more precise than one spot after the decimal. So if my least precise number was one spot after the decimal, telling somebody again that that was a guess, then my answer needs to be one spot after the decimal. Common mistake is somebody's going to say, okay, well 3.6 has got two significant figures, so my answer can only have two significant figures. No. We're just trying to figure out how far after the decimal we should go. So just one spot after the decimal, so that means I need to round to point something. So I got 0.6 right now. Does that stay or does that round up? And in this case, it would round up. So we'd have 30.7 meters as our appropriate answer.